Hello and welcome to day 4. Today we're going to be practicing points, lines, and planes. A lot of yesterday's vocabulary is going to show up here. And what I'm going to do is I'm going to show you a slide, kind of go over it, and then I'm going to give you an opportunity to pause the video so the class can watch this first part of the video. Then I want you to pause it. Because then what I want you to do is I want you to try the activities 3 through 8 and then come back to the video, because then I'll go over those and I'll go over those with detail. But I want you to try that first. And then I want you to pause the video again a second time and then go to the next set of activities. Now here, I'm going to scroll down just so you can see that. It's 1 and 2, and then 3 through 14. So still true and false. Not a lot of work, not a lot of notation, but a more complicated picture. Okay, so let's start out. Today is day 4 in your packet. We are practicing points, lines, and planes. And I should probably say here, if you are a student who at some point does need the geometry SOL, they will not test you on these types of problems. They will not test you on your ability to interpret points, lines, and planes as a problem. However, the reason we teach them is because they expect you to be able to use that notation and use those terms on the test. So you could see them inside a problem and you would need to know what they mean in order to be able to do the problem. So these are what we call like the basic building blocks of geometry. So this is the slide that I kind of want to go over with you in some detail. The thing about geometry that I learned after I took it was that it's very visual. There's a lot of pictures. And the ability to look at a picture, figure out what's happening, take a minute, think about it is very important. So in all of these pictures, there's something or more than one thing going on. Okay? So let's just go through each one. If you look at this first picture, hopefully you can see that there are 2 arrows. So this is a line. Because there's 2 arrows, that makes it a line. That means that it's going to go in both directions forever. Now, what's happening here is a little dot is on the line. That represents a point, and that point is named point P. Now, this line has what we call a nickname. I don't know if you remember that from previously, but here this little m, it's kind of written in a script, and I'm going to demonstrate that. They like to do like little script nicknames for lines and for planes. Like you can, so if I skip down here, you can see how there's kind of like a script and kind of like cursive, a P and a script M. Those are your clue that you have a nickname. So continuing looking at this, line M contains P. So that means that line M has point P contained on it. Or line M passes through P, because if you drew that line M, you would come into contact with point P. So these are all ways, these words here are all ways of describing this particular scenario. So if we come over here and look at this scenario, before I even read their words, I'm going to say, okay, here I have a line L. See, it's got like a little cursive L script. And here I have another line. That would be line M again. And I know that they're lines because I see 2 arrows and 2 arrows. I also see a dot labeled T. So that means that that's a point T. So what they're going to do down here below is they're going to describe what's happening. Lines L and M intersect in T, Or you could say at point T or at T. Another way of describing it is point T is the intersection of L and M. So think about L and M kind of being like streets. T is the intersection. T is where the stoplight is. And then point T is on M, point T is on L. It's actually on both of those lines. You could also say line M and line L contain T. So there's lots of different ways to describe what's happening in the pictures. Okay, let's take this up just a little bit more of a notch here. Now, here we have a line Y, and it's doing this with the fancy script Y. But there's also another line here, and I'm looking to see, it's green. I'm looking to see what that little, I think it's a script X, like they did something like that. So you have two lines. But what's really happening is that these lines are somehow coming into contact with this green surface. And this green surface is a plane. Now, it just looks kind of like a piece of paper, but really what's happening with the plane is it's endless. It's going to keep going out in every direction. It just doesn't have arrows on it because it's hard to put arrows on a two-dimensional shape. So what they've done with the green surface, the plane, is they've given it a nickname. They've given it a script N, and my N's not exactly like their N, but you get the idea. When there's a nickname for a plane, it's usually in the corner. See here with the P, the script P? It's usually in the corner. And it doesn't have a dot with it. See how none of these script names, whether it's a line or a plane, none of them have a dot with them. So if they don't have a dot with them, that's another indication that they are a nickname for that shape. So we have line X, we have line Y, we have plane N, and we have point R. Now the interesting part about line Y is that it has this little, and I'm going to highlight it, it has this little dashed area. What's really happening with line Y is it's coming in from the top. So it's above the green surface. So imagine the green surface and then imagine a line coming down vertically from above and cutting through that surface. Well, where it's cutting through is at point R, and then it's going to continue out below the green surface. So it's traveling in a vertical direction. So it's moving from above the green surface, touching the green surface at R, and going below the green surface. It's a really tough concept to understand because that's really a two-dimensional or a three-dimensional behavior. Trying to see that on a piece of paper is very difficult. So this is how we represent it with the little dashed line right here. And that's how you know it's cutting through the plane, but it's continuing on below the plane. So there are lots of ways of describing what's happening here. Here we have line X and point R are in N. So they're in the green surface area. Now, all of line Y is not in N because some of it's above and some of it's below. So you can't say that line Y is in N, but line X is. It's laying in the green area. Point R lies in N. That's true. Plane N contains point R and line X, just another way of saying it. Line Y intersects plane N at R. Point R is the intersection, oh, this is interesting, of line Y with plane N. That's kind of complicated. So where that green surface and that line intersect, that's happening at point R. And lines Y and X do not intersect. That's actually true, but it looks like it's false. It's really hard to show. Maybe the adult in the room can show you that. They're just not really touching each other in real life because one's above and one's below. And then one's laying on the green surface away from it. So in this last scenario, it has gotten even more complicated because now we have a green surface P, which is a plane, but we have a yellowish, orangish surface, and that's a plane also, and that's Q. And so where those two planes intersect is along this line segment. It's not this whole line. Sorry, my cat just had a bad dream. In case that scared you, that scared me. But it's not along this line segment here. It does not include this little tail of the line and this little tail of the line. It's just here that they intersect. So I see a plane P, a plane Q, a point A, and a point B. Now they're naming that line differently. Notice that it doesn't have a nickname. That line is now, sorry, I have my eraser. That line is now being named AB with the little line symbol on top. So you can see down here, and we're going to read that in just a second. So line AB is in plane P. Well, yes, it is. And it's in plane Q. Yes, it is. Points A and B lie in both planes, P and Q, which is true. Planes P and Q both contain that line AB, but only part of that line. Plane, at least in the picture, in real life, it does contain the whole line. Planes P and Q intersect on line AB, and that's true. Where the yellow part meets the green part, that's right here on that line. And then line AB is the intersection of those two planes, P and Q. So that's a lot of words. And why did we go through that? Because there's a lot of ways to express what's happening in these pictures. So what I'd like you to do is pause the video at this point. I'd like you to come over here. You're going to only be answering true or false. It's going to talk about some of the vocabulary from yesterday. So if you need to go back to yesterday's notes and look at what's coplanar and what's collinear, then go ahead and do that. Go ahead, pause me now. I'll be back in a sec. Okay, so hopefully you got through 3 through 8, okay? I'm going to roll through them kind of quickly. Now remember, collinear means that the points are all on the same line, or I could draw one line through those points. So hopefully, let me get a pen. Hopefully you saw that points A and B and C are not collinear, but they are coplanar. They are on the same blue surface. B and C and D are not coplanar because D is above the plane. Now, does point C lie on line AB? That's false. It does not. Because line AB would keep doing this, forever. And C is all the way over here. How about line AB? Does it lie on this plane ABC? Yes, it does. And does DE, this is a tricky question. Does DE lie on the blue plane. And that answer is false. Now you might be thinking, yeah, but Miss Lucas, it touches the plane, but all it's doing is starting out from above the plane, intersecting it at B, and continuing on below the plane. So if they had taken this word and taken it out and instead said intersects or cuts through or passes through or something along those lines, then it would be true. But it would have to lie on the plane in order for it to be true, the way it's written. So let's do this again. Let's take a couple more minutes, pause the video, and try 1 through 14. Okay, now this picture, if you struggled a little bit with it, I get it, because this picture is much more complicated. You have a lot of things happening here. I see plane Y, I see plane X, I see line AB, I see line, I don't know what you want to name this, CH or CD or something like that. And then I see this segment, FE, and then I see this point G sitting out there. So there's all kinds of stuff going on here. Okay, so name the two planes in the above figure. Well, the easy way to name the planes is by using the script. But if you want to name the planes with 3 letters, remember that those 3 letters have to be on different lines. So I can do A and B, but I can't use H. I would have to use like A and B and G, or B and H and G. You're going to need that G in there. And then to name this plane, the vertical plane that's going up and down, I don't think you can name that with 3 letters. There's just not a good way. That's another name for X. There's just not 3 points that you can use that are on that plane. Okay. Number 2, list the points. So we see an A, we see a B, we see a C, a D, an E, an F, a G, and an H. I think that's it. Now, why didn't we write X and Y? Because they don't have dots, so they're not points. So if you put X and Y, go ahead and get rid of those in your answer, because these do not have a little dot next to them, so they're not points. Those X and Y letters, those are nicknames for the planes. Okay, so true or false? A, B contains H. So let's look at line AB. Yes, it does. Number 4, CD, it's a line or a line segment, contains B. No, it does not. Plane X, so that's the one that's laying down flat, contains line AB. Yes, it does. And G. Yes, it does. CD passes through H. Yes, it does. Because here's CD and it's passing through H. X and Y intersect at CD. Well, here's X, here's Y, here's where they intersect. That's not true. They intersect at FE. X and Y intersect at EF. Yes, that's true. Are A, B, and H collinear? Are they on the same line? Yes, they are. Are C and G and B and A all on the same plane? No, they're not, because the C is up above, whereas G and B and A are all on X. Now here they fixed it, right? C, G, and A. Oh, wait, is that true? Wait, C, G, and no, they're not. They're not coplanar. I thought maybe they fixed it. How about A, B, and C? Are they collinear? No, they're not. Are A and C collinear? It's kind of a trick question. I mean, the way it's drawn, no. But could they be? Any 2 points can have one line drawn through them. So I would have accepted true or false in this case. It's really true, but in the way that the picture was drawn, it was false. Now CD intersects plane 8X. Okay, so hang on, let me erase so I can see. Okay, so that's CD intersects plane X at H. Yes, that's true. Oop, need a pen for that. So that's true. So there you have. Okay. Hope that helps. Thank you very much.